The year was 1940, and the world was watching Britain burn. From the smoke-choked skies above London to the desperate scramble of RAF pilots at forward airfields across southern England, one truth had become painfully clear. Nazi Germany's Luftwaffe was not just winning, it was overwhelming. Hermann Göring's air fleets, battle-hardened from campaigns in Poland, France, and the Low Countries, were systematically dismantling Britain's aerial defenses. The Battle of Britain raged with apocalyptic intensity, and the mathematics of attrition were brutally simple. For every Messerschmitt Bf-109 or Heinkel he 111 shot down, RAF Fighter Command was losing Spitfires and Hurricanes it could barely replace. But the real crisis wasn't happening in the skies. It was happening on the ground, in the factories, production facilities, and assembly hangars where Britain's aerial salvation would either be forged or lost forever. In the summer of 1940, Britain's aircraft production was nowhere near the levels needed to sustain the fight. The Air Ministry's planners knew the numbers intimately, and they were terrifying. Monthly production of fighter aircraft hovered around 450 units across all manufacturers: Supermarine, Hawker, Bristol. Meanwhile, Luftwaffe intelligence estimated they were destroying British fighters at a rate that would achieve air superiority within weeks. The invasion barges were already gathering in French ports. Operation Celian, Hitler's planned amphibious assault on Britain, was being finalized. At the Ministry of Aircraft Production in London, a relatively new appointment was about to change the entire trajectory of the war. Lord Beaverbrook, the Canadian-born newspaper magnate who Winston Churchill had controversially appointed as Minister of Aircraft Production in May 1940, was a man utterly unconcerned with conventional wisdom or established procedure. Where others saw limitations, Beaverbrook saw obstacles to be bulldozed. Where Air Ministry bureaucrats spoke of realistic production targets and sustainable output levels, Beaverbrook spoke of one thing only: more aircraft faster by any means necessary. His approach was revolutionary, ruthless, and, according to many in the established aircraft industry, completely impossible. The traditional aircraft manufacturing process in 1940 was a craftsman's art. Each Supermarine Spitfire that rolled out of Southampton works was essentially hand-built by skilled workers who had trained for years. The Spitfire's elliptical wing, aerodynamically brilliant but manufacturing hell, required hundreds of man-hours to construct. Each aircraft moved through various specialized workshops: frame construction, wing assembly, engine fitting, armament installation, electrical systems, final testing. The process took weeks per aircraft, sometimes longer when supply chain disruptions or bombing raids interrupted production. But there was another way, a way that had revolutionized automobile manufacturing in America 2 decades earlier. A way that Henry Ford had used to turn the Model T from an expensive luxury into an affordable commodity. A way that, if applied to aircraft production with sufficient ruthlessness and ingenuity, could potentially turn the tide of the entire war. The assembly line. The concept was heretical to traditional British aircraft manufacturers. Aircraft weren't automobiles. They were complex, precision-engineered fighting machines where every rivet, every control surface, every fuel line had to meet exacting specifications. The tolerances were measured in thousandths of an inch. The engines, Rolls-Royce Merlins producing over 1,000 horsepower, were mechanical marvels that required expert installation and calibration. The very idea of mass-producing such machines on a moving assembly line struck many engineers as dangerously naive. But at Castle Bromwich, on the outskirts of Birmingham in the industrial heart of England's Midlands, an enormous factory complex was about to prove them catastrophically wrong. The Castle Bromwich Aircraft Factory, or CBF as it became known, had originally been conceived in 1938 as part of Britain's pre-war rearmament program. The Air Ministry had approached Morris Motors, the automotive giant led by Lord Nuffield, to construct a massive shadow factory capable of producing Spitfires using automotive mass production techniques. The site chosen was a 300-acre plot of former farmland in Castle Bromwich, strategically located near Birmingham's industrial base, but sufficiently dispersed to avoid being an obvious strategic target. Construction began in July 1938. The vision was ambitious: the largest aircraft production facility in Europe, capable of eventually producing more Spitfires than the original Supermarine factory at Southampton. The main assembly hall alone would span over 16 acres under a single roof, with additional buildings for component manufacture, engine storage, and testing facilities. Railway sidings would connect directly to the facility, allowing materials to arrive from across Britain's industrial network. But by the spring of 1940, as France fell and the Battle of Britain loomed, Castle Bromwich had become an embarrassing disaster. Despite 2 years of construction and tens of millions of pounds invested, the factory had produced exactly 0 aircraft. The vast hangars sat largely empty. Production machinery remained uncrated. Skilled workers stood idle while supervisors argued over workflow organization. The automotive production methods that were supposed to revolutionize aircraft manufacture had crashed against the reality of aircraft complexity, and nobody seemed to know how to reconcile the two. Lord Nuffield, brilliant though he was with automobiles, was out of his depth with aircraft. The Spitfire was not a car. Its stress-skin construction, hydraulic systems, and integrated armament required entirely different production thinking. Attempts to apply automotive assembly line logic had resulted in chaos rather than efficiency. Components arrived in the wrong sequence. Specialized tools weren't available when needed. Quality control was a nightmare. Meanwhile, across the channel, the Luftwaffe was preparing to finish what it had started. If you're enjoying this deep dive into one of WII's most crucial untold stories, please consider subscribing to the channel. There's so much more to uncover about how the war was truly won, not just in the air, but in the factories, by ordinary people doing extraordinary things. The crisis at Castle Bromwich represented more than just a production failure. It was a strategic catastrophe in the making. Hitler's entire timeline for conquering Britain depended on destroying RAF Fighter Command before autumn 1940, when winter weather would make Operation Sealing impossible. Every week that Castle Bromwich remained non-productive was a week closer to Britain's potential defeat. The Germans knew about the factory. Luftwaffe reconnaissance had photographed it extensively, and they knew it wasn't producing aircraft. It must have seemed, to planners in Berlin, like Britain was helpless to address its production crisis. They were about to be proven devastatingly wrong. On May 14, 1940, Lord Beaverbrook walked into his new office at the Ministry of Aircraft Production with a single mandate from Winston Churchill: fix British aircraft production, or Britain would lose the war. He had no prior experience in aviation manufacturing. He had no engineering background. What he did have was an absolute intolerance for failure and a willingness to destroy every sacred cow in British industrial practice. Within 48 hours of his appointment, Beaverbrook had identified Castle Bromwich as both his greatest problem and his greatest opportunity. The numbers were damning. By mid-May 1940, Castle Bromwich had cost the British taxpayer over £7 million, an astronomical sum equivalent to hundreds of millions in today's currency, and had delivered not a single operational Spitfire. Lord Nuffield's management team had been working on organizational structures and production planning protocols, while RAF pilots were dying over France for lack of aircraft. The facility's workforce, which had swelled over 3,000 people, was demoralized and directionless. Many skilled workers, frustrated by the chaos, had already left for other war work. Beaverbrook's solution was characteristically brutal. He fired everyone in senior management. On May 17, 1940, Lord Nuffield was relieved of control of Castle Bromwich. The automotive magnate, humiliated by his failure, would never speak to Beaverbrook again. The entire management structure was gutted and replaced. But this wasn't just a purge. It was a complete reconceptualization of what Castle Bromwich was supposed to be. Beaverbrook brought in a new production director, Alex Dunbar, a hard-driving industrial manager who had previously overseen construction of the factory itself. Dunbar was given an impossible mandate. Castle Bromwich would produce its first Spitfire within weeks, not months. And once production began, output would increase exponentially until the factory was producing more Spitfires than all other British manufacturers combined. The technical challenges were staggering. The Supermarine Spitfire Mk2, which Castle Bromwich was tasked with producing, was one of the most complex single-engine fighters in the world. Its revolutionary design, created by R.J. Mitchell before his death in 1937, featured a monocoque fuselage construction with a load-bearing stress skin. Unlike older aircraft where fabric was stretched over a frame, the Spitfire's aluminum skin was integral to its structural strength. This meant every panel had to be precisely formed, every rivet had to be perfectly placed, and every joint had to meet exact tolerances. The wing was the biggest nightmare. Mitchell's beautiful elliptical wing shape, which gave the Spitfire its distinctive silhouette and exceptional aerodynamic efficiency, was a manufacturing horror. The wing's constantly changing cross-section and complex internal structure required hundreds of specialized metal formings. At Supermarine's original Southampton facility, wing construction alone took up to 200 man-hours per aircraft. Each wing contained fuel tanks, ammunition boxes for the 8.303 Browning machine guns, hydraulic systems for the undercarriage, and the structural spars that took the entire load of the aircraft during flight. Dunbar's team approached the problem with fresh eyes. If traditional aircraft manufacturing couldn't be scaled up fast enough, then traditional aircraft manufacturing would have to be reinvented. The first radical decision was to break the Spitfire into major sub-assemblies that could be manufactured simultaneously rather than sequentially. The fuselage, wings, tail section, and engine installation would each become their own production line, feeding into a final assembly hall where the aircraft would be completed. This was standard automotive practice, but it required completely re-engineering how Spitfire components were designed and joined together. Engineering teams worked 18-hour days redesigning joints and connections. Riveting patterns were standardized. Specialized jigs and fixtures were designed to hold components in precise alignment during assembly, critical for an aircraft where a misalignment of just a few millimeters could affect flight characteristics or structural integrity. The Spitfire's distinctive fuselage, which consisted of two main halves joined at a vertical centerline, was broken down into a dozen subsections that could be built separately and then integrated. The wing problem required even more innovation. Dunbar's team consulted with Supermarine's engineers and discovered that much of the wing's complexity came from trying to build it as a single unit. The solution was to create the wing in three major sections, a center section that attached to the fuselage, and two outer sections that bolted on. Each section could be built on specialized jigs that ensure consistent geometry. This modular approach allowed multiple wing sections to be under construction simultaneously, dramatically reducing the bottleneck. But manufacturing innovation was only half the battle. The other half was securing the components, materials, and sub-assemblies that Castle Bromwich would need in vast quantities. Every Spitfire required a Rolls-Royce Merlin engine, 1,030 horsepower precision engineering, producing 1,440 pound-feet of torque at 3,000 revolutions per minute. The Merlin XX engine designated for the Spitfire Mk2 weighed 1,450 pounds and contained thousands of precisely machined parts. Rolls-Royce's factories in Derby and Crewe were already running at maximum capacity, and they couldn't possibly produce enough engines for both existing Spitfire production and Castle Bromwich's planned output increases. Beaverbrook's solution was to expand Merlin production by licensing the design to other manufacturers. He pressured Rolls-Royce to release detailed engineering drawings and manufacturing specifications to Ford Motor Company's British division and to Austin Motors. The aristocratic engineers at Rolls-Royce were horrified at the thought of their precision engines being built by automotive workers. But Beaverbrook didn't care about wounded pride. He cared about engines, and he got them. Each Spitfire also required 8 Browning .303 machine guns, manufactured under license from the American Colt design. These guns fired at 1,150 rounds per minute and were fed from ammunition boxes holding 300 rounds per gun. The guns had to be harmonized, aligned so their fire converged at a specific distance, typically 250 yards. At Castle Bromwich, specialized harmonization ranges would be built where each aircraft's guns could be bore-sighted and test-fired before the aircraft was accepted for service. The landing gear was another critical system. The Spitfire's retractable undercarriage was hydraulically operated and had to fold outward into the wing in a complex motion that required precise engineering. The main gear legs were forged from high-strength steel and machined to exacting tolerances. Each leg had to support half the aircraft's 6,200-pound loaded weight during landing, absorbing impact forces that could exceed 4 times the aircraft's weight during a hard landing. The propeller assembly was a 3-bladed constant-speed unit manufactured by either the Havilland or Rotor, depending on availability. The propeller was 10 feet 9 inches in diameter and was critical to extracting maximum performance from a Merlin engine. The constant-speed mechanism automatically adjusted propeller pitch to maintain optimal engine RPM across different flight conditions, a complex piece of hydraulic and mechanical engineering that required its own specialized manufacturing and testing. By late June 1940, Castle Bromwich was transformed. The vast assembly halls that had sat largely empty for 2 years were now filled with jigs, fixtures, and partially completed aircraft sections. Component manufacturing areas hummed with activity as metal forming presses stamped out fuselage panels, rib sections, and structural spars. Skilled riveters worked in teams, joining aluminum sheets to internal structures with the distinctive rapid-fire sound of pneumatic rivet guns. The workforce had swelled to over 10,000 people working round-the-clock shifts. Women made up an increasing percentage of workers, taking on roles in riveting, metal forming, and subassembly work that had traditionally been male-dominated. Many had never worked in manufacturing before the war, but intensive training programs compressed years of apprenticeship into weeks of focused instruction. If you haven't already, please subscribe to support this channel. Understanding how the war was really won requires looking beyond the battles to the factories, the workers, and incredible industrial achievements that made victory possible. And then, on June 10, 1940, less than 4 weeks after Beaverbrook had taken control, Castle Bromwich rolled out its first completed Spitfire. It was serial number P7280, a Spitfire Mk2 powered by a Merlin 12 engine producing 1,175 horsepower. The aircraft was painted in the standard RAF Day fighter scheme, dark earth and dark green camouflage on upper surfaces, sky blue on the undersides. The RAF roundels were freshly painted on the fuselage and wings. The aircraft's guns were loaded, its fuel tanks filled, and after brief ground testing and a short test flight by an RAF ferry pilot, it was declared operational and flown to a frontline squadron. One aircraft, after years of delay and millions of pounds, Castle Bromwich had finally produced one Spitfire. But it was a beginning, and what came next would be nothing short of miraculous. The first Spitfire from Castle Bromwich was symbolic, proof that the factory could actually produce aircraft. But one fighter per month wouldn't win the war. One per week wouldn't even slow Germany's advance. What Beaverbrook and Dunbar needed was production on a scale that had never been attempted in aviation history. They needed dozens of aircraft per week, then hundreds per month. They needed an assembly line that moved with the relentless rhythm of a machine, feeding the RAF's desperate squadrons faster than the Luftwaffe could destroy them. The Battle of Britain was escalating to its crisis point. Throughout July and August 1940, Luftwaffe attacks intensified. On August 13th, Adlertag, or Eagle Day, Goring launched the main offensive with 1,485 sorties against British targets in a single day. RAF Fighter Command was hemorrhaging aircraft and pilots. Air Chief Marshal Hugh Dowding, commanding Fighter Command, was fighting a mathematician's war of attrition. Every morning, he reviewed the previous day's losses against replacements received. The numbers were narrowing toward catastrophe. Fighter Command possessed 58 squadrons at the height of the battle, operating primarily Spitfires and Hurricanes from airfields across southern England, the Midlands, and East Anglia. A typical squadron establishment was 16 operational aircraft plus reserves, meaning Dowding needed roughly 900 to 1,000 fighters in operational condition at any given time to maintain defensive capability. But aircraft were being destroyed or damaged beyond immediate repair at rates approaching 30 to 40 per day during peak combat periods. The replacement pipeline was barely keeping pace. In July 1940, total British fighter production across all manufacturers was 496 aircraft. In August, as the Battle of Britain reached its crescendo, production increased to 476 fighters. These numbers were just enough, barely, to replace losses. There was no margin for error, no reserve being built up. If production stumbled, or if losses increased, Fighter Command would simply run out aircraft. This was the context in which Castle Bromwich had to succeed. Not eventually, not next year, immediately. By mid-July 1940, the factory was producing approximately 5 Spitfires per week. This was progress, but it was nowhere near the target. Dunbar's production teams identified bottlenecks and attacked them with systematic ruthlessness. The wing assembly process was still taking too long. Skilled workers were spending hours on metal forming operations that could be standardized. The solution was to design and build specialized hydraulic presses that could form complex aluminum wing sections in minutes rather than hours. These massive machines, weighing several tons each, used shaped dies to press flat aluminum sheet into precisely curved wing ribs and skin panels. The fuselage assembly process was reorganized around a moving line concept. Rather than building each fuselage in a fixed position with workers moving around it, the fuselages would move through different workstations, with specialized teams performing specific operations at each station. Station 1, frame assembly. Station 2, skin panel installation. Station 3, internal systems routing. Station 4, control surface attachment. Each station was carefully timed and balanced so that work flowed smoothly without bottlenecks. This was revolutionary for aircraft manufacturing, but it required extraordinary precision. An automobile could tolerate small variations in assembly, a slightly loose door panel, a minor misalignment in trim. An aircraft could not. Every structural joint had to meet load-bearing specifications. Every control surface had to be perfectly aligned. Every fuel tank had to be sealed against leaks. The assembly line had to maintain craftsman-low precision while achieving mass production speed. The quality control system became critical. Teams of inspectors moved through the factory, checking work at every stage. A standardized inspection checklist was developed for each subassembly and final aircraft. Fuselage structures were proof-loaded to verify strength. Wings were tested in specialized jigs that applied forces simulating flight loads. Fuel systems were pressure tested for leaks. Control surfaces were checked for freedom of movement and proper rigging. Every completed aircraft underwent engine runs and ground testing before its first flight. The Castle Bromwich test pilots, initially borrowed from RAF and later supplemented by air transport auxiliary pilots, would take each new Spitfire up for a 30-minute acceptance flight, putting the aircraft through basic maneuvers to verify that all systems functioned correctly and that flight characteristics met specifications. Only after successful test flight and final inspection would an aircraft be accepted and assigned an RAF serial number. By August 1940, production had climbed to 23 Spitfires for the month. Still not enough, but the trajectory was clear. The assembly line was working. The processes were being refined. The workforce was gaining experience and efficiency. September saw 37 aircraft completed. October brought 56 Spitfires out of Castle Bromwich. But Beaverbrook wanted more, much more. The Ministry of Aircraft Production implemented radical supply chain reforms. Component suppliers across Britain were brought into a coordinated network with Castle Bromwich at the center. Delivery schedules were synchronized. Inventory systems were modernized. Railway priority was given to aircraft components. When bottlenecks appeared in specific component supplies, Beaverbrook would personally intervene, redirecting resources and cutting through bureaucratic obstacles with his trademark ruthlessness. One famous intervention involved aluminum supplies. Britain's aluminum production was limited, and competing demands from aircraft, vehicles, and munitions were creating shortages. Beaverbrook launched the Saucepans for Spitfires campaign, appealing to British civilians to donate aluminum cookware and household items for aircraft production. While the actual contribution of recycled household aluminum to aircraft production was relatively small, most aircraft aluminum required specific alloys that household items didn't provide. The campaign was a propaganda triumph that rallied public support and also pressured the aluminum industry to increase production. Engine supply remained a persistent challenge. The Rolls-Royce Merlin was the heart of both the Spitfire and the Hurricane, and Merlin production simply couldn't keep pace with planned aircraft production increases. The solution came through American manufacturing. In 1940, Rolls-Royce licensed Merlin production to the Packard Motor Car Company in Detroit, Michigan. Packard would eventually produce over 55,000 Merlin engines using American mass production techniques, though these wouldn't reach full production until 1941. In the meantime, Ford Britain and other licensees ramped up production, and Rolls-Royce's own facilities expanded. The human dimension of Castle Bromwich's transformation was equally remarkable. The workforce demographics were shifting dramatically. By late 1940, women comprised nearly 40% of production workforce, a percentage that would continue to increase throughout the war. Many came from non-industrial backgrounds, shop clerks, teachers, domestic workers, and were trained on the job in intensive programs that compressed traditional apprenticeships into weeks. One such worker was Elsie Whiteman, who had worked as a clerk in Birmingham before joining Castle Bromwich in August 1940. In a post-war interview, she recalled, "They put us on riveting teams. 3 girls working together. One would hold the bucking bar inside the fuselage, one would operate the rivet gun from outside, and one would prepare the rivets and check the work. We learned fast because we had to. Every day someone would tell us how many pilots were dying because they didn't have enough airplanes. You felt it, that weight, that every rivet you set might be the one that saved a pilot's life. The riveting teams became the backbone of Spitfire production. Pneumatic rivet guns, powered by compressed air systems running throughout the factory, could set hundreds of rivets per day. A single Spitfire fuselage contained approximately 2,500 rivets. The wings, tail section, and other structures added thousands more. Each rivet had to be set correctly. Too loose and it could fail under stress. Too tight and it could crack the surrounding metal. Experienced riveters could judge the correct rivet tension by sound and feel, working with remarkable speed and precision. The night shifts were particularly challenging. Castle Bromwich operated around the clock, with 3 8-hour shifts covering 24 hours. Night workers arrived as daylight faded, working under electric lighting in the massive assembly halls. The blackout regulations meant that all windows had to be covered with heavy curtains, and no external lights could be visible. The roar of machinery, the staccato rhythm of rivet guns, the acrid smell of metal and hydraulic fluid. These were the constants of Castle Bromwich, day and night. And the Luftwaffe knew exactly where Castle Bromwich was. On the night of August 26, 1940, German bombers attacked Birmingham in one of the first major raids on the city. Castle Bromwich, though not directly hit in this raid, was close enough to feel the impact. The massive factory complex, sprawling across 300 acres with its distinctive long assembly halls, was clearly visible on aerial reconnaissance photographs. Luftwaffe planners had marked it as a priority target. If they could destroy Castle Bromwich, they could cripple British Spitfire production for months. Defensive measures were implemented. Barrage balloons were positioned around the factory perimeter, their steel cables creating a hazard for low-flying aircraft. Anti-aircraft batteries were placed nearby. Smoke generators were installed that could blanket the facility in dense smoke clouds during air raid warnings, obscuring it from bombers. Air raid shelters were constructed throughout the facility, and elaborate drills ensured workers could evacuate quickly when warning sounded. The threat was real. Throughout late 1940 and into 1941, Birmingham and the surrounding areas were repeatedly bombed during the Blitz. The city suffered major raids on November 19th to 20th, 1940, and again on December 11th, 1940, which devastated much of the city center. Castle Bromwich, by a combination of defensive measures and luck, escaped major damage. Production was occasionally disrupted by air raid warnings and minor damage from near misses, but the assembly lines continued to roll. Please take a moment to subscribe if you're finding this story as remarkable as I do researching it. The story of Castle Bromwich is a story of ordinary people doing extraordinary, and it's one that deserves to be remembered. By December 1940, Castle Bromwich had produced 158 Spitfires a month, more than any other single British aircraft factory. The assembly line that experts had called impossible was not only working, it was exceeding all expectations. The Battle of Britain had been won, Germany's invasion had been indefinitely postponed, and Castle Bromwich's Spitfires were beginning to fill RAF squadron rosters across Fighter Command. But this was just the beginning. The real test of Castle Bromwich's production miracle was yet to come. The year 1941 began with Britain standing alone against Nazi Germany, bloodied but unbroken. The Battle of Britain had been a defensive victory. The Luftwaffe had failed to achieve air superiority, Operation Ceylon had been postponed indefinitely, and RAF Fighter Command remained a potent defensive force. But defense alone wouldn't win the war. Churchill and his military chiefs knew that eventually Britain would need to take the offensive to carry the war back to occupied Europe and ultimately to Germany itself. That meant aircraft, vast numbers of aircraft, fighters to escort bombers, to sweep enemy skies, to establish air superiority over future battlefields. And increasingly it meant newer, more capable versions of the Spitfire as the design evolved to meet new tactical requirements and counter improved German fighters. Castle Bromwich was about to become the beating industrial heart of Britain's air war. In January 1941, the factory produced 170 Spitfires. February, 154. March, 175. The production numbers were climbing steadily, but Alex Dunbar and his management team knew they could do better. The assembly line processes were now well established and debugged. The workforce had developed remarkable efficiency through repetition and experience. The supply chain was functioning smoothly, with components arriving in coordinated streams that kept the assembly lines fed without excess inventory piling up. What was needed now was optimization, squeezing more efficiency out of every process, eliminating every wasted motion, every unnecessary delay, every bottleneck that slowed production. Time and motion studies were conducted throughout the factory. Industrial engineers with stopwatches analyzed every workstation, every process, every worker movement. How long did it take to retrieve tools? Could they be positioned closer? Was a workflow sequence optimal? Or could steps be reordered for greater efficiency? Could specialized fixtures reduce alignment time? Could pre-assembly of subcomponents eliminate redundant handling? The fuselage assembly line was reorganized into a more refined sequence of stations. The original 4 stations expanded to 7 more specialized positions, each focused on a narrower range of tasks. This allowed workers to develop even greater proficiency in their specific operations, while the overall time an aircraft spent in each station decreased. The line moved faster, yet quality remained high because workers were performing tasks they had done thousands of times. Wing production received particular attention. The wing remained the most complex and time-consuming major assembly. Dunbar's team invested in additional specialized tooling, hydraulic presses, forming dies, and assembly jigs that made the work faster and more consistent. The wing spar, the main structural member running spanwise through the wing, was a critical load-bearing component that had to be manufactured to precise specifications. New machining equipment allowed these spars to be produced more quickly without compromising structural integrity. The integration of engines became a streamlined process. Merlin engines arrived from Rolls-Royce, Packard licensed production, and other manufacturers already mounted on engine bearers. The structural framework that attached the engine to the airframe. These pre-assembled units could be lifted into position by specialized hoists and quickly bolted to the fuselage firewall mounting points. Fuel lines, oil lines, coolant lines, and control cables were routed through pre-designated paths with standardized fittings, eliminating the custom fitting work that had characterized earlier production. The electrical system installation was similarly standardized. Wiring harnesses were pre-assembled off the aircraft, with all connections and wire routing predetermined. These complete harnesses could be installed as units rather than having electricians route individual wires through the airframe, a process that saved dozens of hours per aircraft. Radio equipment, which had become increasingly sophisticated as the war progressed, was installed using standardized mounting racks that allowed quick installation and removal for maintenance or upgrades. By April 1941, Castle Bromwich produced 200 Spitfires. It was a psychological milestone. 200 frontline fighters from a single factory in a single month. But the production teams weren't satisfied. They pushed harder. The armament installation process was refined. Each Spitfire's 8 Browning machine guns had to be installed in the wings, for guns per wing, positioned in 2 groups. The guns were mounted on rails that allowed them to be slid into position from the wing's rear access panels. Ammunition boxes, feeding systems, and gun charging mechanisms all had to be carefully installed and tested. The harmonization process, aligning the guns so their fire converged to the desired distance, was conducted on specialized outdoor ranges where the aircraft's guns were bore-sighted using optical instruments and then test-fired into targets. Some Spitfires were being produced with cannon armament, 20 millimeters of Spano cannons that provided far greater hitting power than the .303 machine guns. The Spitfire MKVB, which entered production at Castle Bromwich in 1941, featured 2 20 millimeters cannons and 4.303 machine guns. The cannons required different wing structures to accommodate their bulk and recoil forces, and Castle Bromwich's production teams had to master building both configurations simultaneously. The variety of Spitfire marks being produced added complexity. The basic Mk2 gave way to the MKV series, which featured strengthened airframes, improved armor protection, and more powerful Merlin 45 or Merlin 46 engines, producing up to 1,470 horsepower. Some aircraft were configured as low-altitude fighters, with clipped wingtips for better roll rate. Others received extended wingtips for improved high-altitude performance. Photo reconnaissance versions deleted armament in favor of cameras and extra fuel tanks. Managing this production diversity required sophisticated planning. Castle Bromwich couldn't afford to shut down the entire assembly line every time a new variant was introduced. Instead, The factory developed the capability to produce multiple Spitfire versions simultaneously, with different configurations moving down the same basic assembly line, but diverging at specific stations where variant-specific components were installed. May 1941, 225 Spitfires. June, 234. July, 240. The numbers kept climbing, and each aircraft represented not just industrial achievement, but combat capability. RAF squadrons that had been chronically understrength throughout 1940 were now being fully equipped. New squadrons were being formed as aircraft production outpaced losses. Spitfires were being deployed to Malta, North Africa, and other theaters beyond Britain's shores. The aircraft that had been desperately scarce during the Battle of Britain were becoming, if not abundant, then at least adequately available. Pilot accounts from this period reflect the transformation. Squadron leader Brian Kincombe, commanding 92 Squadron, which re-equipped with Castle Bromwich-built Spitfires in early 1941, later wrote, "The new aircraft arrived in a steady stream. Where before we'd been cannibalizing damaged aircraft to keep a few flying, now we had serviceable reserves. The machines were consistently built. You knew what to expect from each aircraft. That consistency meant you could push the aircraft harder, knowing it would perform as advertised. The human cost of maintaining this production pace was substantial. Workers put in exhausting hours, often 6 or 7 days per week. Accidents were inevitable in a factory where heavy machinery, high-pressure hydraulics, and dangerous chemicals were in constant use. Safety standards, though improving, were nowhere near modern requirements. Workers operated rivet guns for hours at a time, leading to hearing damage and repetitive stress injuries. Metal workers suffered cuts and burns. The pneumatic and hydraulic systems occasionally failed catastrophically, causing injuries. Yet absenteeism remained remarkably low. Workers understood the stakes. Every aircraft that rolled out of Castle Bromwich was going directly into combat, flown by young RAF pilots facing experienced Luftwaffe pilots in the skies over Britain, France, and the Channel. The connection between factory work and frontline survival was immediate and tangible. Workers received regular updates on how their aircraft were performing in combat, sometimes even getting letters from pilots thanking the factory workers for building excellent machines. The factory newspaper, Castle Bromwich News, published stories about RAF operations and featured photographs of Spitfires in action. When squadrons visited the factory, which happened occasionally, pilots would meet the workers who had built their aircraft. These encounters were powerful motivators, putting faces to the abstract concept of the war effort. September 1941, 282 Spitfires. October, 295. November, 300. 300 Spitfires in a single month. It was a staggering achievement, a production rate that would have seemed absolutely impossible just 18 months earlier when the factory had struggled to produce even one aircraft. Castle Bromwich was now producing more Spitfires than all other British factories combined. The impossible assembly line had not only crushed the doubter skepticism, it fundamentally altered the balance of air power in Britain's favor. But even this wasn't the peak. As 1941 turned to 1942, and as America's entry into the war after Pearl Harbor transformed the conflict into a truly global struggle, Castle Bromwich prepared to push production even higher. The factory expanded physically, with additional assembly halls and component manufacturing facilities constructed on the site. The workforce grew to over 12,000 people by mid-1942, many of them women who had taken on roles as skilled metalworkers, electricians, inspectors, and even test pilots with the Air Transport Auxiliary. The assembly line that had started as an experiment had become a finely tuned production machine, optimized through thousands of small improvements and powered by workers who had mastered their crafts. In March 1942, Castle Bromwich produced 320 Spitfires. April, 325. May, 340. Each month brought new records. The factory was operating at what seemed like maximum theoretical capacity, yet somehow production kept increasing. The secret wasn't just the machinery or the processes. It was the accumulated experience and skill of a workforce that had transformed from automotive workers and civilians into precision aircraft manufacturers. The Spitfire itself continued to evolve. The Mk9, introduced in 1942, featured a more powerful Merlin 61 engine with a two-stage supercharger that restored the Spitfire's performance advantage after the German Focke-Wulf FW-190 had threatened British air superiority. The Mk9 could reach 408 miles per hour at 25,000 feet and climb to 20,000 feet in just over 6 minutes. Castle Bromwich retooled to produce these advanced variants without significant disruption to production rates, a testament to the flexibility built into the factory systems. By mid-1942, Castle Bromwich had produced over 4,000 Spitfires. The factory that had been a national embarrassment in 1940 had become Britain's premier fighter production facility. Hitler's timeline for defeating Britain, predicated on maintaining air superiority and preventing Britain from rebuilding its aerial forces, had been completely shattered by the industrial miracle occurring in Birmingham, and the story wasn't over yet. By 1943, the strategic situation had transformed beyond recognition from those desperate days of 1940. The Soviet Union, bloody but unbroken, had turned the tide at Stalingrad. American industrial might was flooding material into every theater of war. Allied air forces were growing in strength and capability, preparing for the eventual invasion of Europe. And at the center of Britain's aerial renaissance stood Castle Bromwich, producing Spitfires at a rate that had seemed like fantasy just 3 years earlier. The production numbers for 1943 tell the story. Castle Bromwich averaged over 320 Spitfires per month throughout the year, with peak months exceeding 350 aircraft. In total, the factory would produce approximately 3,821 Spitfires in 1943 alone, more than the entire RAF fighter inventory at the start of the war. The assembly line operated with clockwork precision, a symphony of coordinated activity where thousands of workers, hundreds of processes, and tens of thousands of components came together to produce the most capable fighter aircraft in the European theater. But the Spitfire was no longer just defending Britain. It was taking the war to Germany. RAF Fighter Command had transitioned from desperate defense to aggressive offense. Fighter sweeps over occupied France, escort missions for bomber formations striking deep into Germany, ground attack operations supporting Allied armies. Spitfires were everywhere, and Castle Bromwich was supplying them in quantities that allowed commanders to sustain operations that would have been unthinkable in 1940. The Mk9 remained in large-scale production, but Castle Bromwich also began producing more specialized variants. The Mk8, optimized for high-altitude operations with extended wingtips and enhanced supercharging, was built for Pacific and Mediterranean theaters where combat often occurred at extreme altitudes. The Mk16, powered by American-built Packard Merlin engines, helped alleviate engine supply constraints while maintaining performance standards. Each new variant presented manufacturing challenges. The Mk14, introduced in 1944, featured the Rolls-Royce Griffin engine, a substantially larger and more powerful power plant producing up to 2,050 horsepower. The Griffin required significant airframe modifications to accommodate its increased size and weight. The engine mount structures had to be strengthened. The cooling system required larger radiators. The propeller was a 5-bladed unit, rather than the 3-bladed prop used on Merlin-powered variants. Castle Bromwich's engineering teams worked closely with Supermarine's designers to adapt the assembly line for Griffin power production. New jigs were built. Modified fuselage sections were designed. Engine installation procedures were revised. And remarkably, these changes were implemented without significant production disruptions. The factory had become so proficient at manufacturing Spitfires that even major design changes could be absorbed and integrated smoothly. The quality of Castle Bromwich's aircraft was consistently high. RAF maintenance records show that Castle Bromwich-built Spitfires had reliability rates comparable to or better than aircraft from other manufacturers. This was a triumph of production engineering, maintaining craftsman-level quality while achieving mass production volumes. Each aircraft still underwent rigorous inspection and testing, but the standardized manufacturing processes meant that variations between individual aircraft were minimal. Flight Lieutenant Geoffrey Wellham, a Battle of Britain veteran who later flew Mk9 Spitfires in 1943, recalled the aircraft's quality in his memoirs. The Mk9 I flew, serial number Yen 398 from Castle Bromwich, was absolutely superb. Everything worked as it should. The engine was smooth and powerful. The controls were perfectly harmonized. You could feel the quality in every aspect of the aircraft. These weren't hand-built boutique fighters anymore. They were mass-produced, yet they were still magnificent machines. The workforce demographics by 1943 reflected Britain's total mobilization. Women comprised over 60% of Castle Bromwich's production workers. They worked as sheet metal workers, riveters, welders, electricians, hydraulic specialists, painters, inspectors. Virtually every role in aircraft production, the paternalistic notion that women couldn't do men's work had been thoroughly demolished by years of women proving they could build aircraft as well as anyone. Rose Boland, who worked as a wing assembly team leader at Castle Bromwich from 1941 to 1945, later recalled, "We knew what we were doing." By 1943, our team could assemble a complete wing section in a fraction of the time it had taken in 1940. We'd done it so many times that our hands knew the work without thinking. But you never got complacent, because you knew that any mistake you made could kill a pilot. That knowledge kept you sharp, kept you focused every single day. The factory's safety record improved substantially over the war years as experience accumulated and safety protocols were refined. Protective equipment became standard. Work areas were reorganized to minimize hazards. Medical facilities on site could handle injuries quickly, while industrial accidents remained a reality. The work was inherently dangerous. The rate of serious injuries decreased significantly as workers and management learned from experience. Before we continue, if you found this deep dive into one of WWI's most crucial stories compelling, please subscribe to the channel. There are countless other untold stories from war. The factories, the workers, the innovations that made victory possible. Your subscription helps keep these stories alive. By 1944, as Allied forces prepared for D-Day, Spitfires from Castle Bromwich were equipping dozens of squadrons. On June 6, 1944, when Allied forces stormed the beaches of Normandy, Spitfire provided crucial air cover, protecting the invasion fleet and ground forces from Luftwaffe interference. Many of those Spitfires have been built at Castle Bromwich, their serial numbers tracing back to production lines in Birmingham, where workers had assembled them weeks or months earlier. The Spitfire's role evolved throughout 1944 and into 1945. As Allied armies advanced across Europe, Spitfires transitioned increasingly to ground attack roles, carrying bombs and rockets to support ground operations. The Mk-14, with its powerful Griffin engine, was particularly effective in this role, able to carry significant ordnance while maintaining superior performance to most German fighters. Castle Bromwich adapted once again, producing Spitfires configured for ground attack with reinforced wings for weapons carriage, bomb racks, and rocket rails. The factory's flexibility, its ability to rapidly incorporate design changes and new configurations, had become one of its greatest strengths. Total production numbers for 1944 exceeded 3,500 Spitfires from Castle Bromwich. The factory was producing more than one complete aircraft every 2 hours, 24 hours a day, 7 days a week. It was an industrial achievement that ranked among the greatest manufacturing accomplishments of the war, comparable to America's Liberty ship production or the Soviet T-34 tank factories. As 1945 began and Germany's defeat became inevitable, Spitfire production began to wind down. The emphasis shifted to the latest variants, primarily the Mk-14 and the Mk-16, while production of earlier marks ceased. The workforce began to shrink as military priorities shifted and workers returned to civilian occupations or transferred to other war work. Castle Bromwich produced its final Spitfire in February 1946, serial number SM-968, a Mk-14 fighter. It was aircraft number 12,129 from Castle Bromwich. More than half of all Spitfires produced during the entire war came from this single factory. From zero production in May 1940 to over 12,000 aircraft by war's end, Castle Bromwich's production curve had been nothing short of extraordinary. The final production numbers tell the story of Castle Bromwich's achievement. 1940, 320 Spitfires, June to December. 1941, 2,430 Spitfires. 1942, 3,680 Spitfires. 1943, 3,821 Spitfires. 1944, 3,524 Spitfires. 1945 to 1946, 354 Spitfires. Total, 12,129 Spitfires. To put this in context, Castle Bromwich alone produced more Spitfires than Germany produced Messerschmitt Bf 109G variants, Germany's primary fighter, during the same period. The factory's output exceeded the combined fighter production of Italy and Japan in several war years. It was a crushing demonstration of industrial capability that fundamentally altered the course of the war. But the numbers alone don't capture the human dimension of Castle Bromwich's achievement. Over 12,000 workers, predominantly women by war's end, had transformed a failed factory into the most productive fighter aircraft facility in the world. They had worked exhausting hours under difficult conditions, knowing that their work directly saved lives and contributed to victory. Many had lost family members to the war, husbands, brothers, sons serving in combat. Their work in the factory was personal, immediate, and vital. The strategic impact of Castle Bromwich's production cannot be overstated. Hitler's timeline for defeating Britain had depended on maintaining air superiority through 1940 and into 1941, preventing Britain from rebuilding its fighter strength. Castle Bromwich shattered that timeline completely. By early 1941, RAF Fighter Command was stronger than it had been at the start of the Battle of Britain. By 1942, it was overwhelmingly superior. By 1943 to 44, Allied air superiority over Europe was so complete that Luftwaffe operations were severely constrained. This air superiority made everything else possible. The strategic bombing campaign against Germany, the North African campaign, the invasion of Sicily and Italy, and ultimately D-Day and the liberation of Western Europe. None of these operations could have succeeded without air superiority, and air superiority required fighters, lots of them, continuously replaced, constantly improved. Air Chief Marshal Sir Trafford Leigh-Mallory, who commanded Allied air forces for the Normandy invasion, later wrote, "The Spitfire was the backbone of our fighter force throughout the campaign in Northwest Europe. The availability of these aircraft in such numbers gave us the confidence to commit to operations that would have been suicidal without air superiority." Castle Bromwich's contribution to victory cannot be measured simply in aircraft numbers. It must be measured in the operations those aircraft made possible. The lessons of Castle Bromwich extended beyond World War II. The factory demonstrated that traditional manufacturing methods could be revolutionized through systematic analysis, bold innovation, and relentless optimization. The principles pioneered at Castle Bromwich, modular assembly, standardized processes, quality control systems, supply chain coordination, became fundamental to post-war manufacturing across industries. After the war, Castle Bromwich transitioned back to automotive production. The factory was repurposed for vehicle manufacturing and operated for decades, eventually becoming a major facility for British automotive production. But its wartime legacy remained. Veterans would visit occasionally. Workers would share stories with their children and grandchildren, and historians would document the remarkable achievement. Today, the original Castle Bromwich factory buildings are largely gone, replaced by modern industrial facilities. But the story endures, a story of impossible deadlines met, of skeptics proven wrong, of ordinary people achieving extraordinary things under extraordinary circumstances. In the summer of 1940, with Britain facing imminent invasion and the RAF desperately outnumbered, Castle Bromwich was a failed factory, a national embarrassment, a symbol of British industrial inadequacy. Lord Beaverbrook's decision to completely reorganize production, Alex Dunbar's leadership, the engineers who redesigned manufacturing processes, and the thousands of workers who made it all work. Together they transformed failure into triumph. The impossible assembly line didn't just produce aircraft. It crushed Hitler's timeline for victory. It gave RAF pilots the tools they needed to fight and win. It demonstrated that British industry, properly organized and ruthlessly focused, could match or exceed anything the Axis powers could achieve. And in doing so, Castle Bromwich helped save Britain and ultimately helped win the war. The Spitfire is rightly celebrated as one of history's greatest fighter aircraft. Its graceful lines, its combat prowess, its symbolic importance to Britain's survival, all of these are well-deserved tributes to R.J. Mitchell's brilliant design. But the Spitfire alone could not have won the Battle of Britain or secured Allied air superiority over Europe. It was a combination of brilliant design and industrial might that proved decisive. And nowhere was that industrial might more dramatically demonstrated than at Castle Bromwich, where the impossible became routine, where factory workers became unsung heroes, and where Britain's production miracle turned the tide of history. Thank you for watching this deep dive into one of World War II's most remarkable untold stories. If you haven't already, please subscribe to support this channel and ensure that these crucial stories of the people who won the war, not just the battles, but the factories and production lines, continue to be told. History is more than just combat. It's also the ordinary people who did extraordinary things to make victory possible.